The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All righty. So today we're just going to answer review questions that you or whoever has. Bring it on. So you got any questions?
On homework 8.9, questions 16 and 17.
Okay, give me just a second here. And we'll bring that up. Okay. Point 9. And you said which ones?
Number 16 and 17.
Okay, 16 and 17.
I struggle with word problem.
Sure, I understand. All right, let's take a look at it here. 16, it says, solve the problem by writing a variation model. The power in watts lost in a resistor in the form of heat varies directly as the square of the current in amperes passing through it. The constant of proportionality, which I've referred to as the variation constant, K, is the resistance in ohms. What power is lost in a 6 ohm resistor carrying a 3 amp current? Okay, so what have we got? We've got the power in watts. So how about if we call P is the power in watts? Let P equal that. Lost in a resistor in the form of heat. Varies directly as the square of the current. Let's let C equal current. Okay, passing through it. All right, so we're talking direct variation. So we're going to have P equals K times C squared, because it says the power varies directly as the square of the current. So P equals K C squared. Are you okay with where I got that?
Yes.
Okay, so now my formula looks like this. Okay. Let's see, this was number 16. Let's write that up here, number 16 from 8.9. Now let's go back and take a look again. It says, what power is lost in a 6 ohm resistor carrying a 3 amp current? Okay, let's see. What power is lost in a 6 ohm resistor carrying a 3 amp current? So P is the thing we're looking for. It says the constant of proportionality is the resistance, okay? So that means that K is 6. And then carrying a 3 ampere current, that C is 3, but that's squared. So let me go back here. So P equals 6 times 3 squared. 6 ohm resistor, and it talked about that the resistance was in ohms, the constant of proportionality, so K is in ohms. And then carrying a 3 amp current is 3, and that's squared. So that's 6 times 9, which is 54, and that would be watts. So that would be your answer. You okay with that?
Yeah, I just got lost with all the OHM and then the ampere. I'm just like,
Yeah,
what?
I know. There's a, and the thing that the tricky thing that you've got to pick up on is that the K is the resistance in ohms. So when it says 6 ohm resistor, that is K. And that's a little tricky. I will be the first to admit.
I put 6 equals K because we've been usually finding like
Yes.
K, what K
Yeah.
equals.
Yeah, I understand. And again, here it doesn't come right out and say the variation constant is 6. You have to kind of put together the fact that it's units in ohms and it's units in ohms. A little tricky, definitely. All right, and then 17 you want to look at as well?
Yeah, so I kind of had it down, but I'm not sure if I did it right or kind of set it up right, I guess you could say.
Okay, and I'm looking at your answer, which is half of the correct answer. So let's see what went wrong here. The pressure of a certain amount of gas is directly proportional to the temperature measured in on the Kelvin scale and inversely proportional to the volume. Okay, so we've got P, which is going to be the pressure. Let's see here. And T is going to be the temperature in degrees Kelvin. And C is going to be, oops, I'm looking at the wrong one there. We're not using C. Okay, I started looking at 16. So 17, we've got
V for
pressure.
volume.
Sorry? Yeah, V for volume. Yes. Oops. V for volume. So I've got P for pressure, T for temperature, and V for volume. And it says the pressure, so P, is directly proportional, so K times T, the temperature, and inversely proportional to the volume. So I've got P equals KT divided by V. You okay with where I got that?
Yes, that I have down.
Okay. It says a sample of gas at a pressure of 1 atmosphere, so that's P, so 1 equals, occupies a volume of 1 cubic meter, so volume would be 1 at a temperature of 234 degrees Kelvin, 234. Okay, now, let's see here. So what I'm getting is this. Again, it says a sample of gas at a pressure of 1 atmosphere, so the pressure is 1, occupies a volume of 1 cubic meter, so the volume is 1 cubic meter, and temperature is 234 Kelvin. Okay, now, based on that, basically I've got what 1 equals 234 K, divide both sides by 234, K equals 1 over 234. All right.
Yes, I got that down.
Okay, so now we've got P equals 1 over 234 T all over V. I just took this and put it back in place of K in the general formula.
Okay.
All right, now the follow-up question. It says, oops. When heated, the gas expands to twice its volume, but the pressure remains constant. To what temperature is it heated? All right, so let's see here. What does it say? When heated, the gas expands to twice its volume. So then the volume would become what? 2, right? Because it was 1 before. So the volume is going to be 2, but the pressure remains constant, so it's still 1. what is the temperature, okay? So we kept the pressure the same, we doubled the volume. How did that affect the temperature? You okay with that?
Yes.
All right, so let's deal with this thing. I'm going to recopy that on the next page, so I've got a whole page of room to work with. So let's see here. 1 equals 1 over 234t all divided by 2. Okay? Yeah. So we need to solve for t. So first of all, let's multiply both sides by 2. So I get,
for the volume, we wouldn't write 2V.
sorry?
For the volume, we wouldn't write 2, because I wrote 2V, and that's why I was kind of confused. I was like, well, why is there still kind of V in, you know?
Okay. Let's go back to, in the original problem, the volume was 1 cubic meter, okay? It says when heated, the gas expands to twice its volume. So it's going to be 2 cubic meters.
Okay.
In other words, we're still using the same scenario. We're not starting all over. And I get where you're saying that. So
yeah, I think that's very messed up.
Yeah, I get that. I know this. Some of these are easier to follow than others, definitely. Okay, so let's see, where are we at here? So are we okay?
Yes.
So this is going to reduce out. We're going to have that. Then I'm going to multiply both sides by 234. And I'm going to get T equals 468. And that's going to be degrees Kelvin. So basically what's going on is by doubling the volume, keeping, no, let's see, wait, what did we do? By doubling the volume, it also doubled the temperature because the pressure remained the same. Okay, you all right with that one?
Yes.
Yeah, that's a tricky one. Right, any others from the 8.9 that you want to look at?
Just question 1 on the review.
Okay, let's go to that. Question 1 on review. Yes. Now, let's say that in the room next door, there are 2 people, John and Maria. Okay? I'm going to walk into the room and I want to know how old John is. What question am I going to ask and who am I going to ask it to?
John, and how old he is?
Right. Am I going to ask Maria anything?
Yes.
What?
Just, well, how old she is, right?
I don't know. I just want to know. Don't add to the story. I just want to know how old John is.
Okay.
So Maria really doesn't have anything to do with the scenario. She just happens to be there, right?
Yes.
Okay, why am I saying all this ridiculous stuff? Okay, here's why. Problem number 1, it says let f of x equal 9x plus 8 and g of a equal a squared minus 4a plus 4 all over 2. We want g of 8. Well, what do we do with f of x equals 9x plus 8? Absolutely nothing. That's Maria. We're not asking about Maria. We're asking about g of 8. So we're only dealing with this. And the reason I'm saying that is because what often confuses people, I don't know if this was your case, but they look at this and they go, well, what are we supposed to do with that? Nothing. We're wanting to know what g of 8 is. Well, why is it there? Is that there to confuse us? No, you have to sort through what you're given to determine what you're going to use. That's life. Okay. Does that make sense?
Yes, it has now made sense.
There you go. Thank you, Maria. So G of A equals A squared minus 4A plus 4 all over 2. And we want to find G of 8. So G of 8 is going to be 8 squared minus 4 times 8 plus 4 all over 2, which is 64 minus 32 plus 4 over 2, which is 32 plus 4 over 2, which is 36 over 2, which is 18. So G of 8 equals 18. And we don't know how old Maria is. We don't care. All righty.
Now I understand it.
You betcha. Any other questions you've got?
No, that's pretty much it. The other one I can figure out now.
Yeah, number 2 is pretty much the same thing. They're giving you more information than you need. You got to figure out which information do I need to use. All right. So no other questions?
No other questions.
All right. Well, what I'm going to do is I'm going to pause the recording. Continuing on, what do you got?
Question 10. It has the word problem saying if it's true or false, and I'm honestly confused.
Okay. So let me get back in there. If I'd known you were coming back, I'd have left it in there, but that's okay. And
It was my bad. I forgot to check.
okay, it's all right. Not a problem. So what did you say it was?
Question 10.
From the chapter review or the 8.9?
8.9.
Okay. You know, I saw that earlier and I almost asked you about it, but I thought, well, maybe she's okay. All right, let's see here. So the language of variation is often used to describe various aspects of the internet and websites. Determine whether each statement, generally speaking, is true or false. All right, it says the dollar amount of sales that an internet website receives is inversely proportional to the amount of internet traffic that visits the website. Okay, let's think about this. Would you think that the more traffic would produce more sales or that more traffic would produce less sales? Which would you think?
More sales.
Okay, so as traffic goes up, sales go up. As traffic goes down, sales go down, right?
Yes,
Is that direct or inverse?
that is direct.
Okay, so the dollar amount of sales an internet website receives is inversely proportional. So that would be false, the first one. Okay,
Okay.
that makes sense?
I'm confused on how to do those questions. I was like, do I just answer from like what I know or what?
Well, yes, from what you know, but what you've got to realize is that how does direct work?
Inversely and
Yeah,
directly
yeah.
joint.
Okay,
Okay.
take a look at the second one. The download time of an internet website varies directly with the bandwidth being used. Okay, so if you increase the bandwidth, does it increase the time it takes to download?
What is bandwidth?
Ah, all right. Okay. And I am by no means an internet expert, but think of it this way. Think of it as instead of the information traveling through a bandwidth, think of water traveling through a pipe, okay?
Okay.
So the bigger the pipe, the more water can travel through it at a given time. Does that make sense?
Okay.
So if you got a wider bandwidth, that's going to increase the amount of information that can be passed through for a given time. Does that make sense?
Kind of. I'm trying to make it make sense.
Okay. The bigger the bigger the bandwidth, the more information can be passed through it in the same amount of time.
Okay.
Okay. So it says the download time of an internet site varies directly with the bandwidth being used. Well, if you increase the bandwidth, you would increase the amount of information that can be sent, which would mean your download time would be faster, wouldn't it?
Yes.
So it says the download time varies directly, but the download time would actually decrease because it would happen faster. So this is not direct, this is
Indirect.
inverse.
Inverse.
Increase the bandwidth, decrease the download time.
Okay.
Yeah, and again, I can see how not understanding how that works makes it a tricky question. And again, I'm no expert. All right. Search engines like Google place a value on a website that is directly proportional, that is, varies directly to the number of sites that link to it. So if you've got a website that's linked to a whole bunch of sites, would that be more valuable to a search engine like Google, or would that be less valuable?
More valuable.
So is the value, does it vary directly with the number of sites linked to or not?
Yes.
Yes, so that would be true.
Okay. I understand it now.
Awesome.
Thank you.
You bet. Any other questions at the moment?
No, that is it. I am done. I just have to take the test now.
All righty. I'll pause the record. All right. Well, since nobody else is showing up, I'm going to call this review session, call it quits. Just a reminder, I'll be back at 1:15 this afternoon with an office hour. Your test is on Monday. There will be no class Zoom meeting at the regularly scheduled time on Monday. You are just to take your Chapter 8 test, and you can take it anytime from now till Monday night at 11:59 p.m. So have a great weekend, and we'll be gone now. Bye.